Hello, my friends. Welcome to Origins. I'm Donn Chapman. It's my privilege to be your host. You know, Origins is a forum where we take the evidence of science, we use it to validate the truth of God's creation. And one of the best ways we do that is when we can find creation scientists who will come and be with us and share what God has taught them so that we can share that with you to show you how science is constantly validating, if we'll just have eyes to see, the truth of His creation. We have a great scientist with us today, Dr. Danny Faulkner. Dr. Faulkner, it's so good to have you. How long have you been teaching down there at the University of South Carolina, Lancaster?
I started there in 1986.
You've been a few years down there,
Yeah.
and you're a tenured professor. And today we're going to talk about Mars and Venus. Now, that's come up in shows we've done before. What's special about today's show?
Okay, the last time we talked about Mars and Venus and the uniqueness of the Earth as a suitable habitat for life.
Right.
Mars and Venus are real hostile places. And I really think that's one of the two reasons perhaps why the Lord gave us Venus and Mars. So in this latter time, with space age, we can actually understand that. But today I want to talk a little bit about the geology on either of those planets and what it tells us about past processes in those two and what it suggests about the flood we think happened, the biblical flood of Noah.
That's fascinating. So we're going to talk about the surface of those places and what's happened there. So please, I'm excited to see what you have for us
Okay,
today.
I got a question for you. What do we call, what's the nickname for Mars? It's called the red planet.
Oh, yes,
The
that's
red
right.
planet.
Okay.
And you can see, I got a photo here of Mars. Let me go up there and just point out to you. It's very red. The whole surface is red because it has iron oxide in the soil and in the rocks.
Okay.
And with the naked eye, it looks like a fairly bright red star. It doesn't, you need a telescope to see the disk. And this is one of the better images that's taken from near the Earth. I think this might be an HST, Hubble Space Telescope photograph. A lot of interesting features. You'll see some dark and light areas on the planet. Down here we have some white, and up here at the top we have some white. Don, do you know what those are?
I'm going to guess water.
Well, not water, but ice.
Okay.
Polar ice caps. Now, as it turns out, most of that ice is actually made out of frozen carbon dioxide. That's also called dry ice. Very cold stuff. But Mars is a fascinating planet. We can see it from the Earth, but when you actually go there, you can see it even more detail. This is actually a photograph made by a spacecraft approaching the planet. And it's neat because you can see this large scar going across the planet. Keep in mind that Mars is about half the size of the Earth. This large scar here is called Valles Marineris. It's a huge canyon, and it would stretch from the east coast to the west coast if this were on the Earth. Wow. That's how big it is. It's huge. Not really carved by water. It's a big rift, we think, opened up. You can see three dark circles over here. Those are large volcanoes, the largest volcanoes in the solar system, maybe in the whole universe. Far bigger than any volcanoes in the Earth. So it's an interesting planet. It's had some processes similar to what we have on the Earth. Let's just take a moment to talk about some of the gross properties of Mars. It's about half the size of the Earth. It has only 11% the mass of the Earth, and its gravity is about 39%. So if you weigh 100 pounds on the Earth, you only weigh 39 pounds on Mars. It's also about half as far away from the sun than we are, so already it's going to be a colder place, you might imagine, being that far away from the sun. But it does have a tilt of 24.5 degrees, or about 25 degrees. Ours is 23.5 degrees. This means we have seasons on Mars, just like we have on the Earth.
So the tilt is very similar to our tilt.
Yes, it is. In fact, you know those ice caps, they grow during the winter and they shrink back in the summer. And that was an evidence people used at one time to suggest that maybe there was a lot of water on Mars. Also notice this rotation rate, just a little over half an hour longer than ours. So I think if you move there, you could get used to having 40 minutes longer in each day.
So you're seeing all these similarities. It's easy to see how people speculate life on Mars.
Oh, yeah. People thought at one time that maybe life was there. H.G. Wells wrote about it.
Yeah.
You know, about the time H.G. Wells was doing that, there was a famous astronomer named Percival Lowell who looked at Mars. And he, back about a century ago, had a big theory about Mars. He could see these little straight lines on Mars that he thought were canals to transport water. We don't see any large bodies of water like oceans, but he thought, being a desert planet, maybe the polar ice caps, when they melt in the spring, Martian civilization had built these canals to transport water to the tropics where more people live. You think that's kind of far-fetched, but you know, out in California and out in Arizona, they have hundreds of miles of canals where they transport Colorado River water and other sources, great distances. So this is not as far-fetched as you might think. So it's a desert planet. Maybe these canals were transporting water. He also saw color changes from kind of green to brown from spring to fall, and he thought that was chlorophyll changing with plants. He wrote a series of books and a series of lectures and magazine articles. He thought that there was a race of people superior to us on the surface of Mars.
Now, he didn't interview any Martians.
No, this is a long time ago.
Just speculating.
Now, you go forward about 50 years after his death, the space race starts. We end up going to Mars with several different space probes starting in the 1960s and continuing well into the 21st century now. And as they did this, they found that Lowell's Mars didn't exist. No. The canals were just an illusion. There were optical illusions that he saw there. And the planet's very different. First of all, we found the atmospheric pressure is only 1% that of what we have at the surface of the Earth. Not even 1%, actually. You would have to go to an altitude of 100,000 feet to find the kind of pressure on the Earth that you have all the time on Mars. It's also very cold. On a very warm day in the tropics, the rocks might actually get above freezing, but the air temperature never even gets close to 0 degrees Fahrenheit. A really warm day on Mars typically is like 40 below. Wow. And then before daylight, the temperature probably plunges to nearly 200 below, even in the tropics. So it's a very cold place, very low surface pressure. It's obvious we can't live there, and it's doubtful that any kind of living things could exist on the planet. There is very little water. We do know that a little bit, one of the polar ice caps has a little bit of water on it, and we've actually detected it in a vapor form in the atmosphere. But there is no liquid water. We know that from the temperature and the pressure. If you were to spill some water out on the surface of Mars, a portion of it would freeze immediately or pretty rapidly, and the other portion would boil away. So liquid water can't exist. Huh. And that's pretty common throughout the universe. We find water in abundance in the universe, but it only exists in the vapor or in the solid form, never in the liquid form.
So far as you know, only here on our Earth do we have liquid water.
Yes.
That's amazing.
We have a couple of satellites of Jupiter that are hints that water may exist below the surface, but we're not sure about that. Okay. So this is the only place in the universe where water definitely exists in a liquid form, definitely not on Mars. But we do know, this is very interesting, water, while it's very rare on Mars today and not in liquid at all, at one time, water, in fact, liquid water, was very abundant on the surface of Mars.
So there was a time when it could sustain liquid water and had a lot of it.
It must have been a warmer place with a thicker atmosphere and a lot more water. And big question is, what happened to the atmosphere? What happened to the water? Well, the atmosphere probably evaporated away, and the water did too over time. But what was going on before that, that's the big mystery, and people have speculated quite a bit on what this could have been. How do we know this? Well, there are river channels on the surface. I'll show you some photos of this in just a moment. Not like the canals. These are real river channels like you'd see on the Earth. We also, and there is some clue that there may have been catastrophic flooding on the surface. They see some ridge lines up on the hillsides that look like shorelines, hundreds of feet up, even thousands in some cases, suggesting that there was once a global flood or near global flood. We see drainages on nearly flat land of the surface. And we see these shorelines I mentioned, suggesting that once water was very deep over a good deal of the surface. This is some of what I was talking about, the drainage here. You can see there's a large stream down here. Maybe the red's not working so well. Up here, you can see tributaries. You find this branching coming together. And, you know, I don't know, Don, if you've ever flown over the west, over Arizona, New Mexico, you look out of the plane, you see stuff like this, don't you?
Yes, you do.
And it drains off very nicely. You can see where the rain precipitated, fell here, flooded down, and ended up working its way on down from there. This is another black and white photo. The other one was color. There's a meandering stream here.
It really does look like a riverbed, doesn't it?
It does look like a riverbed. You got a little island, looks like, over here. A couple of craters or impact craters on the surface of Mars. But even on a small scale, you can see this. This next photograph is one of my favorites. I first saw this photograph probably in the late 70s, and I immediately knew what it was when I saw it. Notice there are a couple of craters right here. Here's a crater right here, and here's a crater right here. And what do you see? Well, there's kind of a teardrop shape here, isn't there? And there's a teardrop shape right there as well.
Yes, sir, I see that.
And you know what? When I was a kid, I had a paper route, and I went by some construction sites, and they had bare dirt, and it would rain, and water would wash down. I didn't know I was doing geology at the time, but I would see these gullies get cut with tributaries, and occasionally, particularly in a kind of a wide area where the water was flowing kind of shallow, not in a big gully, you'd see a brick or a piece of 2x4. an obstruction sitting there.
Right.
And the water would hit that obstruction, flow around, slow down on the backside, drop its sediment, and you get a teardropped island right there.
Oh, okay.
So when I saw this, I knew what I was looking at. In fact, what I'm actually looking at here is it tells me the water was flowing in that direction. So when I saw, even as a kid, I knew what caused that, and as an adult I saw this, and I thought, that's amazing. Liquid water once on abundance on the surface of Mars, so there's plenty of evidence. Now, where did the water go? One possibility is some of the water may be frozen in the ground, what we call permafrost, in the rocks and the soils. This is a crater we call Uti, and this is an interesting one because it's a good-sized impact crater here. Notice this debris field around here.
Okay.
Sometimes at the beach you might see this. The sediment the wave will come in, crash, it will kind of swash back. When it does, it drops this load of sand, and it leaves that kind of pattern. We think what happened here is it melted subsurface water, had a slurry of rock and soil and in water, and then it froze out and froze in that position. So there may still be water deep in the surface of Mars. It just is frozen today. We don't know for sure. That's just one possibility. And then why look for life on Mars? That's been one of the big things we've had with the space program over the decades, looking for life on Mars. Well, if life evolved on Earth, there's the evolution word again, it should have evolved elsewhere. Otherwise, it makes the Earth unique. And so they want to find a place where life might have done this. So recent years, we found organisms living in very hostile environments here on the Earth, like in the deep ocean vents and underneath glaciers in Antarctica, things like this. So they're suggesting now that life may have even originated in these places. You know, when we were at school, we thought they all told us it was in this primordial soup in a warm place. Now they're saying it's in a hostile place, and then it colonized the nice places. And there's an agenda here. I think they're trying to say, well, maybe life could have evolved on Mars as well, as hostile as it is today. So most people today don't think life exists on Mars today, but it may have existed in the past. So look for fossils is what they're trying to do. Looking for life on Mars, or past life on Mars, that's something they want to
desperately find.
Now looking at Venus, it's a different kind of planet. It has a similar size, mass, and density. Sometimes we call it Earth's twin because the two planets, as far as their gross properties are concerned, are so similar. It has an atmosphere, though, it's very different. I talked about that in the other program that we did on Venus. And the atmosphere is very dense, full of CO2. It's a very hot atmosphere, very hostile, even worse than Mars is in many respects. 90 times the pressure that we have at the surface. Extreme greenhouse effect of 900 degrees on the surface.
900 degrees.
Yeah.
So Mars is too cold and Venus is too hot.
And we're the Goldilocks planet. We're just right in between these. Now, we can penetrate the dense clouds with radar. We've done that with a couple of spacecraft. And what we find are these big continent-like structures on the surface of Venus. Very similar to what we find on the Earth, because we find areas of continents that stick up and ocean basins that fall down, and the water fills up the ocean basins for that reason. It's no accident that we have continents and ocean basins.
What are the basins filled with on Venus?
It's empty because there's
They're
no
just
liquid
empty.
water there. Now, remember, there's no water on
right.
Mars. So what they also see is evidence of rapid plate motion, tectonic activities, volcanic eruptions in the past. We find craters on Venus. They tend to be very sparse, but they tend to be fairly uniform. And we can look at the shape of the craters, what we call the morphology, how sharp they are, and get a relative idea of the age. And they all appear to have about the same vintage. And so, Don, this is what gets me excited. The uniform wearing on the pattern here and the sparseness and the uniform density of craters, it suggests that the entire surface of the planet of Venus was worked over with rapid plate motions sometime in the past, done in a very brief interval of time. And you know what, Don? It's not creationists saying this. This is the secular evolutionary astronomers. They believe that Venus once went through a catastrophic episode of plate motion and volcanic activity, and then quiescence since then.
And then got quiet after that.
Yeah.
I think I see where you're going with that.
That's
fascinating.
Very
fascinating.
fascinating. We would disagree with the time scales, how long ago that was, but we all agree within our time scales it was a brief episode. And I was a creationist, a catastrophist. I say, yes, I believe Venus had catastrophic activity, as do the secular scientists as well. Here is a radar image put together. It's false color. These areas that are kind of brown looking, those are continent-like areas. They have higher elevations. The deep blue areas are like ocean basins. They're deeper. They color code that because on the Earth you would have water here and plant and maybe mountains there. but it's...
we're using those just to contrast
Yes,
height.
it's false color.
Yeah.
But these would be like continents here and be like ocean basins. Here's the other side of the planet. Again, some continent-like features and then some ocean basin-like things. And lastly, here is one of the impact craters from the surface of Venus. And you'll see the ring of the crater right there. It's got a flat bottom. And this right here is called the Ejecta Blanket. And that's debris that was blown out from when the crater formed. And it looks pretty sharp. This is a radar image. It's false color. It's not a true color. But that sharpness is similar for all of them, telling us that these are fairly young craters on Venus. That's the reason why they believe in the catastrophe across the surface of the planet.
Folks, you don't want to go away, because I think there's some fascinating information we're going to gain that's going to help us understand planet Earth from what we learned from Venus and Mars. So you stay with us. We'll be right back.
Today's guest on Origins, Dr. Danny Faulkner, is also the author of Universe by Design, an explanation of cosmology and creation. This is an excellent book for upper-level homeschool curriculum or the library of an astronomer. Orders are being taken at 1-877-CRS-BOOK. Dr. Faulkner has a degree in math, his master's in physics, and a PhD in astronomy from Indiana University. He is full professor at the University of South Carolina, Lancaster, where he teaches physics and astronomy. For more information about our guest, you can write to Dr. Danny Faulkner, 1402 University Drive, Lancaster, South Carolina, 29720. Or send him an email.
We're back with Dr. Danny Faulkner, and we're talking about Venus and Mars and about the surface of them. And you kept bringing up the word catastrophe. I'm fascinated now. Will you do some comparison of these worlds and see how that relates to us?
Yeah, I think there are two things that we can learn about Mars and Venus. And I think it's providential that the Lord made these two worlds close to us. I think this latter time, the 21st century, we can actually go here to those planets and study them up close. It's telling us a couple of things about the Earth, perhaps.
Okay.
We talked in another program already about how hostile Venus is and how hostile Mars is to life. First of all, Venus is very hostile because it's very hot there, 900 degrees temperature. You're not going to even solder. A lot of metals can't exist in a solid form. They turn into liquid on the surface. And the atmosphere is very dense, the wrong composition. It's high up, trying to get through it with a spacecraft. Even you've got sulfuric acid droplets.
We've landed
on Mars.
On Mars. We've not landed on Venus, but the Soviets have tried.
Back in the 70s and 80s, they tried it a number of times. For a long time, I thought that was kind of bad projects, bad program. But it turns out that's a tough engineering thing to do. And my hat's off to them. They really did some hard stuff there. Maybe one day we'll try that, but it's pretty hostile. And Mars is hostile too. It's very cold, a very desolate sort of place, and the atmosphere is extremely thin. So we're like the Goldilocks planet, yes, not too hot, not too cold, just right. Not too much atmosphere, not too little atmosphere, just right. In all these times.
Put us in the right place.
And distance is important, but turns out the distance is not the only thing, because the moon is the right distance, and yet it's dead. Today, I really want to concentrate upon the Earth. In the past, we creationists, taking Genesis seriously, we believe there was a flood a few thousand years ago, recorded in the Bible with Noah building the ark. It lasted for a year.
Worldwide flood.
Yeah, worldwide. And if you look at the passages there, it's not talking about water prevailing on the Earth, but it suggests what we call volcanic or tectonic upheaval. We think two processes went on at that time. Perhaps you had a lot of volcanic activity, rapid plate motion. Plate tectonics is this idea of how the world works, how the surface is to be interpreted. We think that was very active at the time of the flood. Now, of course, the evolutionists say, well, that's silly, that's nonsense. You couldn't have a worldwide flood on the Earth, and you can't have plate tectonics, but at least happening that fast on the planet. But when you go to Mars, what do you find? You find evidence that water was once there, even though there really is no liquid water today. Also, abundant evidence that there was a global or near global flood on the surface of the planet. Now, they're in a position of telling us that they believe a huge flood could have happened on Mars, a body in which there is no liquid water today, but it couldn't happen on the Earth. Then you go to Venus, and again, the secular scientists, everybody agrees that at one time there was this catastrophic plate and volcanic motion taking place on Venus, but again, they deny that it could ever take place on the Earth.
So when you look at the two of them, two of the huge things they tell creationists couldn't have happened because of the flood. We see one happen on Mars and one happen on Venus.
Yes,
Okay.
and it's like the Lord said, okay, if you don't want to believe this, fine, but I'll show you. I can do it on one, make it real simple for you,
Yeah.
and then I'll do the other over here to show you that it can happen on
Object lessons.
Yes, object lessons. And you know, it's fascinating because, again, one of the major models we have for the flood is what's called catastrophic plate tectonics, which came out before all this information about Venus, and right after they presented this information, the information from Venus came. And I said, wow, you got plate motions, catastrophic plate tectonics taking place in this. So they deny either one could happen here. They deny that you could have a flood where we have plenty of water, but they believe there could be a flood on a planet where there is no water. So I think in summing this up, we've got some real lessons here for us. Both Mars and Venus show how special the Earth is. And also, we find out that both Mars and Venus reveal processes that we creation scientists think happened during the flood. And I don't think it's any accident that the two closest planets tell us that. So when people ask me, you know, what kind of purpose is there in the different planets? I haven't all figured it all out. I mean, I don't know why Jupiter is the way it is. I don't know why Saturn's the way it is. I have some ideas. But when it comes to Mars and Venus, I have some very specific ideas about why those planets are the way they are. If we put water on the Earth, on Mars today, it would quickly freeze and quickly evaporate and be gone.
Okay.
And so obviously Mars at one time had a much more substantial atmosphere, and it can't hold on to an atmosphere because its gravity is so low. Now everybody agrees that the lack of gravity, the low gravity it has, I should say, allowed the atmosphere to leave, which allowed the water then to evaporate and leave the planet. The question is, how did Mars get an atmosphere to start with? If it doesn't have the gravity to hold on to an atmosphere, it shouldn't have gotten one to start with. So I think as an evolutionist, that would be a little bit of a difficulty. To the creationist, I think God created Mars with an atmosphere and with water on it.
Yeah.
But then over time, it lost it.
All right. So that makes sense. Now, when you're talking about Venus, you kept pointing out that it seemed like you had craters that said something had happened rather recently. What are those craters from?
Some sort of impact event. We've got another talk we're doing on craters as well. We can talk about that as well. But craters are pretty common in the solar system.
And is that what moved the plates?
No, it actually happened after that.
Okay. All right. So this is really fascinating stuff. So bringing it back to Earth, and we say that the Bible teaches us there was a flood. Result of the flood, there was really some catastrophe moving things, huge shifts on the Earth that transformed and changed everything. And when the evolutionists say, no, 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 everything happens steadily and slowly over time, this uniform change, which buys them the billions of years, and we say, no, it could happen very quickly. When they say no, we say, well, wait a minute. When you say flood, obviously Mars had one. It has no water, but you believe in their flood. And you say, well, plates can't move. But we look at Venus, we say, but plates did move there.
Very quickly.
So why can't you have floods and plates moving here?
Plates moving very quickly.
Yes. So both of those things seem to, God almost gave us two object lessons to say, of course I can do these things, and I could have done them here.
That's exactly it.
And the evidence is here that he did them if we'll just have eyes to see.
Change your whole attitude.
Yeah, that's right. So again, it's not our eyes, it's our heart.
Yep.
That's right. Dr. Faulkner, again, I want to say what a privilege it is to have guys like you on our team who are able to look through the telescope and see what God has done and then bring that evidence home to say, and this is what God's done here. We're very blessed to have men like you. Thank you, sir. And friends, I want you to know that when you read God's Word, you're not reading fairy tales, you're not reading myth, you're reading truth that God has recorded, and He's used what He's done elsewhere to validate what He's done here. It just ought to deepen your conviction that you can believe God's Word. I want you to remember that because we live in a world where the worldview isn't always the biblical worldview, but it's God's view He created you, and you should make that your worldview too. So until the next time, I just want you to believe God and believe His Word, and join me again real soon on Origins, won't you? Till then, God bless you, my friend.
Thank you for watching this edition of Origins. To get a copy of the information presented today, you can download a PDF file of program number 1103 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1103, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.